Welcome to Smarter. These videos are intended to help you get up and running as quickly as possible. This video, I'm going to show you how to get yourself set up in your development environment. And there's a few more videos. There's one more separate from this where I'll show you my normal developer workflow to bring the platform up, start up development, write my code, QC it, commit it, and push it to GitHub, and then check out the unit test. All right, let's get started. Okay, first up, let's get this repo cloned. And here's what we're going to do. We're going to clone this repo. I will step you through what you need to know piece by piece and show you a few things. Here we go. Here's our repo. And this repo is private. So if you get a 404 error in GitHub, that means that you lack permissions and you need to speak to Kent Fuka or me, Lawrence McDaniel. Given that you have permissions, pretty straightforward. We're going to clone like this and head over to a terminal window and run git clone as follows. Outstanding, and we are cloned. So before, I know that you're anxious to take a look at the code, but before you do that, I would strongly recommend that first you run make on the command line. And you'll do that for a few reasons. One is because there's a lot of make commands, because there's a lot of automation, because there's a lot of different technology in the repo. But in addition, when you run the makefile, one of the things that it's going to do is scaffold a .env file, and this is of the utmost importance to get you up and running. There's a couple of environment variables that have to be set in order for this code repo to boot itself up inside of the world of Docker. The first four commands that are inside of the make menu, which is init, activate, build, run, and tear down, that's mostly the only commands that you really need to worry about. And so everything that follows are individual commands for troubleshooting or just something that's technology specific. But for the purposes of getting the development environment up and getting the web platform running locally on your computer, all you need are these first 5 commands. All right, I'm going to fire up VS Code. And the first thing that I want you to see is the .env file. And these two environment variables at the very top, this is what I was referring to, is that the code base is sensitive to the environment that it's in. There's a choice of 4, starting with local, then test, staging, and prod. And in addition, the Python interpreter in each of those different environments needs to be explicitly shown where the Python virtual environment exists for purposes of writing code in a code editor, and also where the code base resides, again, for the purpose of your code editor, so that your real-time import checking, these are tools like Flake8 and Black are going to have what they need in terms of the Python path so that they can do their work for you inside of the editor. This has nothing to do with actually running the application software, neither in your local development machine nor the 3 environments that we manage. All right, anything that follows beyond those 2 items are mostly for those of you who work on cloud architecture and are hands-on with Terraform. So if that's not you, then don't worry about the rest of it. Okay, next up. Check your prerequisites. That is, this code base is designed as of this recording to run explicitly on Python 3.11. And so if you're anything above or below that, you're going to hit a brick wall. And so what you'll want to do is install that exact version 3.11. And for that matter, check the README to see what the current Python version is, and just make sure that that is available on your local computer. You also are going to need Docker and Docker Compose, and those are 2 different pieces of software if you're new to that environment. With Docker, I like to use Docker Desktop for development purposes because it's a nice GUI and I can see everything that I need to see inside of the world of Docker to understand how much drive space I'm chewing up, how much memory, and how much CPU, basically. And that's all you need. The software itself requires a lot more than this, but just keep in mind that development and the 3 environments that we're running are all container based, and so Docker. And so the first thing that I think we're going to want to look at um, is that here in the root of the repository, there's a Docker file and a Docker compose file. And it's not a bad idea to just, these are really easy to digest, even if you're new to Docker. Neither of these are very large. So the Docker file itself is less than 100 lines. A lot of that's comments and just setting up environment variables. And so the salient bits of code literally are just like maybe a dozen things. And effectively what it's going to do that's important and noteworthy is that it's going to assure that uh, we're running on, or at least emulating, an AMD 64 chipset, and that matters for Python requirements that are part of the code base, such as SciPy and Matplotlib and a couple other things. And the reason for that is that those PyPI packages have got assembly code inside of them. They have C headers. They have a bunch of archaic source code that's worked really well for 40 or 50 years. And with the caveat that they are kind of pinned to a certain kind of chipset. We also are able to spin up a Docker image that has exactly the sanctioned Python org Docker image for the version of Python that we're running. So both of those are really nice. It gets us out of the starting gate without us falling on our face, so to speak. All right, we can see we get our Python path set up similar to what I was talking about with the makefile. Um, we get a couple of environment variables penned inside of the Docker file to make sure that just when the Python Django code boots itself up, it can find its settings, it understands the different environments, it has what it needs to run itself in three different modes, which is the application mode, a Celery worker, and a Celery beats, a scheduler kind of thing. When we deploy this into Kubernetes, we'll deploy pods for each of those three, and we want to make sure that this Docker file environment covers all those bases. All right, we get apt-get set up with all the package dependencies. The only one that's kind of quirky is getting node set up on Ubuntu, and so it's kind of split apart. But other than that, all we have are just the basic stuff like a MySQL client and a couple of Python helper packages. From there, we install the Python pip PyPI requirements, and there's a special selection of those for the Docker build, which works in your local environment, but also in Amazon Web Services in the Kubernetes cluster. Okay, that's everything that I think we need to know for now to get the application software started up. And so let's kind of work this backwards. We'll get the development local web server running, get the Docker images built. We'll get the supporting services like MySQL and what else? Redis and anything else. We'll get all that running inside of Docker, and then we'll work backwards into the source code. So good? All right, let's do this. All right, so I'm gonna here on the screen. So here's these 5 commands again. Here's what we're gonna do. We're gonna run kind of in this order. We're gonna run make init, which is a process that's gonna take about 5 or 6 minutes if you're starting from scratch. Before you run these, you want to make sure that Docker or Docker Desktop is up and it's running in your computer, not just installed, but running. So here comes Docker. Word to the wise is that when you install Docker Desktop, when you walk into it, you're going to see something kind of like this. It's going to take all the resources, all the memory, all the CPU, a lot of drive space that's available, and allocate it to itself, which is real selfish. And so you immediately, if you're new to all this, want to go straight to this location, go to the cog, go to resources, and drop these down to reasonable numbers, which are the following. For the CPU, you need 1 CPU or less in point of fact. And likewise, with system memory, 2 gigabytes is on the high side. I'd say like that's when you're actually running the software and MySQL is doing things. But when it's sitting idle, it's using it's using kilobytes of memory, not gigabytes. Now, on the other hand, with the drive volume, it needs a lot of drive space. The pods, when built, are about 3.5 gigabytes for the application. Remember that three of those are going to run, and when you're in developer mode and it's watching your source code changes, it's building this cache that unfortunately is keeping track of stuff that you probably don't care about and maintaining an archive of stuff. I don't know why, but it causes a lot of drive space to get consumed. And so it's not unusual for your Docker environment in this project to be consuming 15, 20, 25, 30 gigabytes of drive space. So keep that in mind for planning purposes inside of your dev environment when you're getting all this set up. So here is make a init. All right, and so this process takes about 5 minutes, and so I'm going to abbreviate this in this video, but I'd encourage you to take a close look at the Docker file and acquaint yourself with what it's doing, which is pretty simple. It's as basic as spinning up Ubuntu with Python and then adding system packages, adding PyPI, and then pulling our application in there and getting everything started up. And that's basically it. It's very simple. All right, checking in on our installation. We're at this point, we're about 3 minutes into this. The system packages are installed, the PyPI packages have been downloaded, and it's running through the installation process for each of those packages right now. And that's wrapped up. All right, good. So our second to the last big step is the static asset collection process that's part of Django. That's a little bit larger with this project because we have a React front end that's built into this project, and that needs to be transpiled and then collected by Django along with all the other stuff and put in its final um, serving location in the static assets folder. So that is all going on right now. And since it's a React app, there's Node and there's package requirements from NPM that are specific to the React package. And so we're going through that process right now. You don't really see any console output to that effect, but that's the reason that this line here, step 12 of 13, it's going to take about 90 seconds or so, 90 to 180 seconds, depending on how fast your computer is, mostly because it's got to build that node environment in order to build the React app itself. All right, checking in. We're about 2 minutes into the React build process and it's still running. Okay, we're almost to the 3 minute mark. It just finished with the React build. And now you can see the transpilation process and the asset collection process. So that is pretty quick. That takes a couple seconds. And we're effectively built at this point, and we're exporting layers, and a Docker container is soon to follow. So let me get this set up here. And there we go. So we're built, and now what's happening is we've got to pull in Redis and MySQL Server for your local development environment. Those are the two principal kind of industrial grade services that support the application that you're going to need to have running locally in order to have your own dev environment with the application running. All right, so that's all done, and so our application has just deployed itself inside of Docker Desktop, and so you can now see 5 containers running. 3 of these are the derivations of our Django application that I mentioned, plus MySQL, plus Redis. So our application's starting up right now. First up, we can see Redis booting itself up, then MySQL. Once those are up and running, then we should see the worker and the app. There's the app starting itself up, which means that MySQL is ready. And then we should see the worker and the Celery Beat app. And then once those are all up, then we should be able to go to the browser and hit localhost or 127.0.0.1 at port 8000, and the app should be up and running. So here's our URL for local. And if all goes well, you'll see a couple of lines of activity here in the background. And after several seconds of basically Python objects instantiating and caching themselves in Redis, which is all kind of a one-time deal for you in your local development environment. We should see the app open up. Okay, and there's our app, and we're up and running. Now, just take note that in your local development environment, when you're building this from scratch using this make and init that we just ran, um, the very first time that you start the application, you're initializing a lot of data inside of Redis. And in my case, I have a very ordinary, just MacBook Air laptop that I'm doing this on. And it takes about 60 seconds for that process to run its course. And so it might cast the appearance like something's wrong. It's not, just be patient and let it run its course. Okay, so we're up and running, and that concludes video number 1. In the next video, we're going to look at, I'm going to show you how I work with this infrastructure on my local computer to write software.